let's move to the final presentation by Eugene Siriani from the University of Montreal, and the talk will be about collaborative modeling with AToMPM. Good.
Yeah, so I hope it's all working.
Yeah.
Great. So thanks for having me. This is a great workshop, a great opportunity, a great project you are having, and it's very closely related to some of the research we have been doing in my lab at the University of Montreal. So I will probably go a bit quickly on the introduction part, because if you are here, you probably are quite motivated by the fact that collaborative modeling is important. So I will very quickly just say that why do we collaborate? Well, simply because today any significant software or system is built in teams and not an individual. That brings along the different team members bring along different expertise. Just think about an agile team, for example. And because we are used to working at a distance, not everybody is at the same place at the same time, especially during this 2020 year, we have seen the proof of that. So the collaborative software development usually require different expertise from different domains. I think of an energy efficient tool, an energy efficient building management, where you need different domains, from architecture, material science, environmental science, software engineering, urban planning. That they must work in a coordinated manner. So we need to have communication, consistency between the different artifacts built, and a uniform interpretation of how the system is perceived. And they each work, you can have also sub-teams, not only individuals, but work on different aspects of the system. For example, the energy aware development, the occupation, the maintenance, the demolition, etc. So collaboration situations. So these teams of stakeholders work together to produce a coherent and complete system. So typically there are three situations when individuals within or across teams collaborate: is if they work on the same part of the same artifact, if they work on different parts of the same artifact, or if they work on distinct artifacts but that are part of the whole system. So very quickly, working exactly on the same artifact, this is equivalent to having an active screen sharing collaboration. I would say a la Google Doc, right? Where you can see all the changes are reflected by anyone, are reflected and perceived by everybody. We can work on different parts of the same artifacts. So in this case, we assume that the artifacts, for example, the models, can be partitioned into maybe submodels or views. But of course, for that, we need mechanisms at the language level to be able to split the artifacts. And the third situation I mentioned is where each artifact represents a concern of the overall system. And we basically build the complete underlying model, and underlying system is built by the union of these different concerns. So this is quite related to what Juan was asking in the previous talk. So this brings us to something called multi-view systems, right? As we have seen in the previous talk as well. So these views are useful to customize how the model is perceived. So with the views, we can decide what kind of information we want to show to the specific target user of that view. For example, we can show an aggregation of some of the information of the raw model. We can also decide to represent differently. For example, think of concrete syntax. Maybe one wants to see it in a tabular format, and the other one wants to see it in a graphical format, for example. it also it is useful to decompose a model into views, because this will reduce the conflict rate. So why do we have conflict rates? Well, because imagine you have concurrency and you have multiple people working on, you know, the same model but from different views. Well, if they're working each one on their own views, it is less likely that they will intersect, and that one operation from one user may conflict with an operation that the other user did. It may happen, of course, but it reduces that rate. And finally, it's more from a security and access control point of view. Well, it's a way to also protect your model, so you can have different views with different access rights. For example, one can only, you know, read this part of the model, but can write this other part of the model in his view. You know, think of access rights in views with you know, traditional database systems. Yeah, so it gives you finite granularity. So let me, I will not formally define what a view is. There's ample literature on that, but I will just very quickly say how we are taking view, what we're considering as a view in the context of this talk and the work we've been doing. So here we consider that a view is a projection of the properties of a model, meaning that it projects some of the information which may also be interpreted information. For example, aggregation, you know, we can have the average or the sum of some values, for example. The view can be a proper subset of the model also. So it can be literally the model expressed in the same language, but showing only a subset of the components it has. Or it can be some kind of abstraction of the model by aggregating some of its properties. In this case, the view and the model are expressed in different languages, but they may also be expressed in the same language, but maybe offer different presentations, so different concrete syntax. So when you're engineering a view, when you're creating a view, how do you look at it from a language engineering point of view? If you're used to building domain-specific modeling languages, well, this is maybe for you. So in here, we consider a view as a model as well on its own. Okay, so it has an abstract syntax, a concrete syntax. It has its proper semantics that is given by the mapping to the model. And so the view conforms to its own language, but its language is kind of derived. It's basically a set of mappings, right? So it has the language of the view is basically needs the elements. So what kind of elements will be present in the view, and the mapping of these elements is defined by the abstract syntax mapping from the model to the view, so that we can have a projection of the elements of the underlying model to the view. And similarly, the concrete syntax mapping assigns a proper concrete syntax to the elements of the view here. Okay, so the abstract syntax mapping is specific to one view, and the concrete syntax mapping is also specific to one view. However, the concrete syntax mapping in general, is not necessarily shared across different views. Of course, we must refer to at least one element from the model, but in the view, you can have elements that were not in the model. For example, if you're having an abstraction. And as I said, it has its own concrete syntax. So some underlying assumptions that may seem strong, but are necessary for the work I'm presenting. So we assume the models are stored in a repository, therefore can be shared. Okay, so when I say the word model, it includes also the views, right? Models can only be accessed via their views. So this means that whenever I want to create the first time I want to create the model, the first element I want to put in the model, I actually have to go through a view. So by default, there's a view. There's like a first view where I create my model, and then from that I can spin off other views, and then they create other elements that may or may not be part of the initial view. But at least there is one view for each model. And a corollary of that is that every element of a model exists in at least one view, so that the union of all the elements of the view, right? So the union of all EVIs is equal to EM, right? The set of all the elements of the model. So this means that the underlying model is composed by all the elements of the different views. Okay, so that's for the definitions and the background. So the first thing I want to talk about is some work we have done about multi-view modeling scenarios. So it's very much from a use case point of view, and we identified 4 typical multi-view modeling scenarios. So previously I mentioned there were 3 collaboration scenarios. So they are here, but with multi-view, there's one that is extracted a bit more. So the first one is when 2 users are working exactly on the same view, simultaneously projecting a model, part of a model. The second one is when we have 2 users working on different views, but of exactly the same model. The third one is when we have 2 users each working on a view of distinct models, but there's some kind of link, some kind of consistency link between the 2 models. And the fourth one is when you have one user working on a view that projects 2 different models, while another user is working on a view of one of the models. So let's go a bit more in the details and the challenges that each of these scenarios raises. So in the multi-user single view model, the users are working exactly on the same view. Therefore, they see exactly the same information in the same language. So typically, we use the same concrete syntax between the 2 because it's exactly the same view. Therefore, they are using the exact same concrete syntax. So this is similar to active screen sharing, right? So any change done by user 1 are reflected by user 2. And I will, for each of these scenarios, I will talk about what happens if you have concurrent changes that are conflicting at the same time. So typically in a multi-user single view scenario, this is done this is resolved in a first in first out fashion. So the first one, the first operation that arrives, it happens, and then followed by the second operation. And if the second operation is not allowed, then it is not allowed. The second one is a multi-view single model scenario where each user is working on a different view of the same model. So as I said before, they share the same. They can be presenting the same elements or not. So there may be an intersection between the two views or not. So in the case where for the elements, if one element of a view is changed, but it is not part of the elements of the other view, then the changes are not reflected. But if it is shared, then the changes can be reflected. However, note that here we're talking about the abstract syntax changes. What about the concrete syntax changes? Well, in this case, because each view, V1 and V2, have their own concrete syntax, therefore, if I, let's say, I don't know, I make it bigger, and if I resize an element, and resizing does not change anything in the abstract syntax, so it doesn't have semantic meaning, it's just visual, then that change will not be reflected in the other view, for example. And what happens if you have simultaneous conflict changes? Of course, this only happens if in the shared space of the elements. So there, a conflict management strategy must be put in place, because we have to make sure that the views are consistent with each other. There are different strategies of resolving these conflicts. I will not go through them completely. I will talk about some of them, how we did it in the tool AToMPM, which is the second part of the talk. For the third scenario, the multi-view, multi-model. So in this case, we have users working on different views, and each view is a projection of a different model, but the two models have some kind of dependency that can be expressed in different ways. For example, they can be subject to global consistency constraints. We can have an explicit link, an explicit reference from one element or from one of the models to the other. This reference may also be bidirectional, so that's another case also. Here in this example that I'm giving here, we explicitly have that the M1 has a reference to M2 has a reference to M1, and so E prime can act, for example, as a surrogate or as a proxy of E. There's also another way you can also have this link between the elements by having an explicit model that links, that makes the mapping between the two models. Okay, so you would have an M3 model in this case. So in the case of references, okay, whether they are using an external model or references directly, the reference can be active or passive. So active means that this proxy also allows to perform operation on it, and if it's passive, then it's only a read-only operations that can be applied, and only changes applied on the original or on the source of the reference get propagated to the target. So of course, maybe not all the changes of the source of the element need to be propagated to the other model, or at least to the other view. Maybe it is propagated to the other model, but may not be reflected to the view. And so we need to decide, how, the mechanism of how this change propagation happens. For example, if I delete this element, should it be also deleted here and therefore deleted from the view, or should I leave it there as a read-only, maybe marked as it has been deleted? You can ask whether it must be approved, and so. So that change propagation needs to be mitigated. And about the conflicting changes, so if I, for example, in the active, this can only happen in the active scenario, so active reference scenario. So if here user one makes a modification in his view on E, let's say it changes the value to 1, from 0 to 1, and the user 2 in the second view of the other model that has a reference here to that element changes the value to 0, let's say, then we have a conflict, right? Which one should be resolved? How do we resolve this conflict? And that happens, exactly at that situation. And these kind of conflicts can be resolved in the same way that was done in scenario 2. And the fourth scenario is the single view multi-model. So it's in the case where I have one view here, V2, that is projecting 2 models, and I have someone else working on one of the models, let's say. So in this case, V2 is an abstraction of M1 and M2, right? So we can actually go back to this situation and consider that it's like having an M3 model that refers to these two models, and then I have a view on that one, right? So it's kind of equivalent. And since we consider views as models as well, so basically it is solved usually similar to the previous case. But the dependency is defined at the view level, not at the model level per se. And in this case, we usually have an active reference variant, because any change that happens here or here will be reflected in the view. And so the same kind of concurrency control systems should be applied. So this gives an overview of the different multi-view collaboration scenario possible in the context of a modeling environment. And there are other orthogonal dimensions that we may be wanting to look at. For example, the mode of collaboration. For example, if it's a real-time collaboration or near real-time collaboration, where yes, I have different views, but each one is working on his view at the exact same time. So in this case, usually the different architectures rely on an MVC architecture, where the model changes are propagated almost instantly to the views of interest, and the conflicts have to be resolved as they happen, right? So the users subscribe to a view subscribes to basically defines a projection of the model, and that's how multiple users can interact with the same model, for example. Some situations where some strategies that some tools, for example, OBO Designer, have opted for to control or to handle the conflict management, concurrent conflict management, is, for example, through locking. But as we will see, there are other ways of resolving this issue. And the other mode of collaboration is, of course, the offline mode. So in this case, we have multiple views, but we're not necessarily working at the same time on our views. And usually this follows a decentralized architecture. For example, following Git, like a WebGME uses that. And we have domain-specific or view-specific version control system that allow you to synchronize and commit and basically merge the different changes. So in this case, the views refer to a proxy model, okay, that is usually, for example, local to the session while you're working on the view. And when you decide to commit, right, or to save or to push, then that's propagated to the central model. And so the conflicts only happen when you actually push there. So you can resolve conflicts locally, and then what they claim, especially what the WebGME claim with their experiences, is that having this two-phase, let's say, concurrency management system reduces the conflict rates when it goes online, when it's pushed to the online model. So this is one dimension, okay, that we can look at for a multi-view modeling. But so there are many other dimensions to look at. So in this feature model that was presented a couple of years ago, so we enumerated, some of the requirements for collaborative modeling, and so the first one here is the collaboration scenarios. So these multi-view, multi-user supports that I just described here. With respect to concurrency, so here I opened up just a bit more. So as I said, it's possible to use locking. It's possible to be, to decide whether we're real time or offline. It's also, so another dimension is the versioning. So yes, you can have a version control system even when you're in real time. What happens, how do you deal with history of past operations, and do you allow batch operations or atomic operations only, and how do you resolve the conflict between them? So basically, is it a transactional system, an atomic system, or not? Then there's the data storage. So how is the data stored? The previous talk has mentioned a couple of ways that it's possible to persist the models, and so this falls very well in that framework. There's the network architecture. So what kind of underlying protocols are used to communicate between the different peers or the different clients and the server, etc. How are conflicts managed depending on which level of granularity I want at the view level. For multi-user, so here I expanded also multi-user. So do you need to know who is performing what action? Do you want to control the access of per view or per element, for example? Do you want to know that other people are working at the same time on your view or on elements or on another view that shares elements with your view? And then there are, I always like to talk about undo, redo, and copy paste, because this is just a completely different way of thinking, right? We have to change the paradigm of undo, redo, and copy paste, because what does it mean when I undo something on my view? Should it undo it locally for me, or should it also undo it for all the others? Is it something on my view? Is it something propagated to the model? Is it something that must be reflected to the others? Because imagine if I perform an operation and someone else performs an operation, I expect that my undo undoes what I have done and not what the other person has done. So this brings to interesting research challenges there. Same thing for copy pasting. So I'm not gonna go exhaustively into all that, but so there's different dimensions, different aspects we have to think of when we're talking about multi-view collaborative modeling. And thankfully, there are some tools that support some of these features. And so here, this by no means is a extensive or exhaustive list. And you have seen in this workshop, in the previous talks, other tools as well that fit, that could go here as well. So I just want to talk about some, maybe older tools. For example, like Design Space is an Eclipse-based tool where it's a round robin. So users take turn. So first it's this person, he can work on it. And then when he finishes, then it's the next person. And when he finishes, then it's the next person. So you kind of don't have this, by construction, you don't have these conflicts that happen directly. In Ptolemy, at least the second version of Ptolemy, you can design and execute heterogeneous modeling languages. So the collaboration is done at the language level, but they don't have multi-user support, but they can have multi-language support, and therefore, by extension, multi-view support, but still with a single user. And then you have all the all the online Eclipse spin-offs, like Eclipse Che. So it's basically, I would consider it a bit like active screen sharing there. Gmod Studio, a bit like Ptolemy, allows you to compose multiple DSLs into a cohesive system, but you can't have concurrent users working on it. WebGME is a collaborative version of the older GME tool, where you can share and work on the same model. It's based on a branching scheme like Git to manage concurrent actions. So I mentioned it briefly before. Obeo Designer allows for multi-view and multi-user support. Um, but they enforce locking, and they have made some interesting choices in the locking. So for example, you can decide to lock the concrete syntax, or you can decide to lock the whole model, the whole view, the single elements. So this is more a locking system. And the last one here is AToMPM, which I will talk about in this second part of the talk. So AToMPM is a modeling language workbench that allows you to develop DSLs and model and edit models and manipulate model and run transformation, run simulations, execute your models, all on the web. And it is very concrete syntax driven. So everything you do has to go through the concrete syntax. You do not manipulate the abstract syntax directly. And AToMPM is solely dedicated to graphical concrete syntax style. Yeah, so here are some words on it, some introductory work on it. So it's you have to recall that if you decide to use AToMPM, remember that it's a research framework. It's not a full-fledged commercial tool. So beware that it may have some non-user friendly decisions that have been made there by the accumulation of the different students and researchers that have been working on it. It's open source to framework to design domain-specific editors, execute transformations, and manipulating and managing your models completely in a web browser. So you don't need any installation unless you want to install the server. Of course, you don't need any installation, and it's completely independent from any platform. And it follows the multi-paradigm modeling philosophy, where there we consider everything to be modeled. So as I said, views are considered as models, even toolbars are considered as models. And so you can have when we talk about multi-level of abstraction, well, you can decide to have it's not a strict 4 meta level hierarchy where you have M0, M1, M2, M3, but you can have as many M3s as you want. So we typically see it as MI, MI minus 1, MI plus 1, so that we can have different levels of abstraction and different formalisms and processes to use each DSL. The tool is completely bootstrapped, so it's completely modeled by itself, which may explain some of the maybe not so user-friendly interactions that it imposes. So I'll talk a bit about the architecture of AToMPM with respect to the collaborative part, and how we have implemented this multi-view modeling support of the different scenarios I explained before in AToMPM. So it's a 4-tier architecture, your traditional way of performing cloud-based softwares. So you have a client that is thin, where basically it's just the web browser of the client, and then you have the server. In our case, we rely on a Node.js server that encodes all the communication between the client and the server. And in it, we have a layer before the persistence layer. We have the model view controller layer, but here you will see it's not the MVC architecture that you're used to. We will talk about it here, because model in the MDE way, view in the multi-view way, and controller, which controls the communication between them. And on the rear end, we have the Modelverse, which is basically the modeling repository, which is not necessarily, you shouldn't think about it as a persistence format, but more as a repository, an online repository of all possible models. Basically, that's the philosophy behind it. So very quickly, each of these components. So the client, as I said, is a very thin client, so there's nothing to install. All the models are saved on the cloud, and it's all you need is an SVG compliant web browser because we use HTML5 and SVG there. It allows you to only model graphically. So all the operations, whether you want to create elements, modify their values, delete them, or read the properties of some of the elements, are done through interactive mouse clicking, basically, or shortcuts on your keyboard. And it comes with different tools and a complete plugin infrastructure. And so each DSL is basically like a plugin that you add, and you can add custom tools to perform customized actions. And one of these tools is basically a bulk operation. So you can have this toolbar here, and for example, instead of repetitively creating 5 times the same element, you can just say times 5, and it will create 5 times, for example. We also have different mechanisms. We have complete workflows that are implemented that you can just that will just automate some processes, and you can customize your workflows as you want. So there's many tools, and they're all completely modeled within the tool. On the web server part, so we've chosen a Node.js using a ZeroMQ messaging system. So if you know a bit about ZeroMQ, we use the couple of the protocols like the pub/sub, and I don't remember the other protocol that they have, which are actually quite efficient for communication, and it's compatible with many different programming languages. So it allows for multi-tenancy and multi-user support through socket IO. We also have what we call the AToMPM messaging service. So it is quite nice to think of all the possible ways of resolving conflicts, when we have simultaneous changes that happen at the same time. But some of the time you just can't resolve it automatically, or if one person resolves the conflict, then it may not please the other person who also is part of that conflict. So this is where we have a chat service where they can just communicate with each other and decide how to resolve it, and we found that this way is quite useful in practice. The third part, I'm not really going to talk about it, is just that the execution engines behind are all modeled by a series of state charts communicating with each other, but I'm not going to go into that in this talk. The model view controller component. So as we can see in this figure, so for each model there is a controller, and you can have views subscribing to a controller, therefore to a model. And we have different levels of granularity of controllers. So you have a model controller that so for example here the red one is responsible for model specific requests, for example changing a value, adding an element, etc. You have the package controller that is responsible to non-model specific requests. So for example, they can save or open or load or add a model, or all the other operations that are not specifically modifying the model itself. The node controller is there to do the load balancing between the controller in the node, so that if you have I don't know, hundreds of users at the same time, there's some load balancing being done. And finally, the super controller is just a dispatcher of the messages to the right controller, depending on where it comes from, where it received the request from a socket. So the controllers do not process the operations when model controllers do not process the operations directly. So if I send a request to add an element, the controller is simply passing that request to the Modelverse kernel that acts as an API of the Modelverse. So it coordinates all the operations and ensures consistency and conformance. Currently, we have only one point of entry to the Modelverse, so that's a bit the part where we need to work more to improve the performance, which is not bad. I will show you later. So the MVK receives the requests from the controllers and performs the model operations. For example, any CRUD operation, conformance checking, execution. So we also have an action language that is modeled in the Modelverse, so that you can execute it directly. And finally, the last component is the Modelverse. So it's a standalone repository and considers everything as a model. So including meta models, concrete syntax definitions, models, views, transformation, tools, everything is considered as a model. And we have a physical representation that is that can be different flavors. So depending on which version of AToMPM you install, it may be JSON or it may be a textual syntax, but that is saved just for so you should imagine that the Modelverse is like an operating system, right? It's just always on, and the serialization is only meant for fault tolerance point of view. So in the Modelverse, how do you integrate? Because one of the scenarios we mentioned, the one where you have multiple models with multi-view multi-models, or even single view multi-models, well, we need a mechanism, an internal mechanism at the repository level to be able to compose these models together, or to link these models together. So every model has its own, every model element has its own namespace location, and that's how you can make an explicit reference to that location. And that's how I was talking about the active and the passive reference. So that's a property of the reference you can make there. So you can completely, you can integrate and compose languages, models, whatever you have in whatever artifact you have in your model repository inside as a completely this way. But from a graphical user interface point of view, we only have a restricted version of that. So the multi-view modeling support in AToMPM. So we do support multi-user single view. So that's the first version, the first one that I mentioned. So you can just click on screen share, and it will just give you a link, so you can actively work on the exactly the same model and the same view. Multi-view single model is supported with the model share feature. So you can work on different views of the same model, just the same way. And the multi-view multi-model and single view multi-model are supported in the backend, but are not supported in the front end yet. So just a small word before I conclude on the performance. So we've run some controlled, lab environment, lab experiments inside a controlled environment, where we tested, different dimensions, adding different users, increasing the number of views, increasing the size of the model, etc. And what we have seen is that the size of the model doesn't really influence. So as you see here, the size of the model doesn't really influence the performance. But what happens is that the more users you add, the more variance there is. Okay, so that's basically what we have. And also we see that multi-user single view performs better overall than multi-view single model, and which in turn performs better than multi-view multi-model, which is kind of to be expected. But in general, and you can see here, we did tests up to 200 concurrent requests. You can imagine that in reality, you will probably be within, between 1 and well, not 1, but within 1 and 50. So looking at 50, the times are quite appropriate for the response time and the request duration from the ping to the pong back, basically. So to conclude, I have talked about multi-view support in this talk, but there are other dimensions that I think are necessary requirements for collaborative modeling, but not necessarily sufficient. And that is really looking for, one of the dimensions here is looking at the user perspective. So in this talk, we looked at the view perspective, but what about the user perspective? So supporting multiple user kind of requires you to have a version control system there. And frankly, today, there's no software built without version control systems. So we need to think about version control systems that are adaptable to views, right? Not necessarily using Git or SVN just as is for the repository of your models, but port it to the end user, right? So that he understands in a domain-specific way, in a semantic way, what is a difference, what is a merge, etc. And also the other point of multi-user is to adapt the editors and the environment, the modeling editors to the user. So today most of the tools, we use most of the language workbenches, whether it's AToMPM, Eclipse, WebGME, all of these. When we generate the domain-specific editor, it's for the end user, right? But who built the editor? It's probably a software engineer or a language engineer or something like that. And the generated editor is exactly, so when we generate an editor in AToMPM, well, it is in AToMPM. When we generate an editor for Eclipse, it's in Eclipse. And therefore, you impose the same way the user has to interact, whether he's a language engineer or whether he's a domain expert, he has to interact with the tool in the same way. And that kind of contradicts the philosophy of domain specificity. So we have to make sure that we really, when we say we generate a domain specific modeling environment, that it's really domain specific. And it's not just the text that I can write or the icons that I can draw, but it's also the interaction, the feeling, the semantics, the overall layout, etc. I'll talk more quickly about the other two because I'm probably running out of time. So the multi-paradigm support. So of course, as we said in the introduction of this talk, it's necessary to when we have multiple teams working together, they are not necessarily using the same language. They're not using, they don't have the same expertise. And so they may also be using different paradigms. And so we need good support to enable multiple DSLs, but also composition of heterogeneous languages. And some of the tools I mentioned focus solely on that, and it would be good to also extend it to this multi-view and multi-user approach. And finally, we also have to think about not only the design phase, but also the runtime phase. What happens with the models? When I've created the model, okay, it's not an end, right? It's a mean to an end. So am I going to generate code? Am I going to run simulations? Going to run analysis? Going to do debugging? And so it brings us to how do we do this kind of execution, this runtime, when we have multiple views, when we have heterogeneous models as well? Okay, so these were basically points of discussion, maybe that may spark some discussions for the session. And so thank you very much, and I'll be happy to take questions if you have some.
Thank you, Eugene, for the very interesting presentation. Is there any question you would like to ask Eugene? Right, I can warm up with one question. So Yeah, you made a very comprehensive introduction to all possibilities in collaboration with conflicts, with the different views, and so on. Um, uh, but then you also saw performance measure with up to a lot of users, no, or more than 50. But I wonder if you have so many users, you will probably have a lot of conflicts, no? People moving things around, and do you support some kind of protocol or some kind of role mechanism that can somehow organize a team of engineers working on the same view at the same time?
Yeah. So I was. It's thanks for asking this question because I was thinking of adding, something about that in the slides, but for time I didn't do it. So yes, this is something that we have run into, and when you have an extreme, we can consider that 200 concurrent users is an extreme case. You will have a lot of conflicts, and therefore it's not possible to ask them to, resolve the conflicts themselves each time. It's 200. If you do the Cartesian product, then you're exponentially augmenting the number of possible conflicts. So they will be spending more time resolving conflicts and merging than actually doing the work that they need to do. So we've been recently working. I have a master's student who graduated a year ago, and now we have a postdoc taking the lead on that project. Is looking at real time. How for the real time part, not for the offline part. For the real time part, how do you manage concurrent users? And actually, we rely on a protocol called CRDT. So. Conflict-free data structures. So basically, they are data structures where you encapsulate your models and your elements inside the data structure that, by definition, by construction, will resolve conflicts automatically. So I can, probably not say too much about it, but there's a lot of work that happens on that in the parallel and distributed system community that try to resolve that, and so we're relying on that part.
Mhm. Yeah, looks very good. I think we have a question in the YouTube chat by Mohammad Reza Sarbab. So, very sorry for the pronunciation. The question is, how does AToMPM work for semantic conflicts and conflicts that depend on the modeling language?
Yep. Yeah. So so if you're asking how does AToMPM resolve that, I will tell you it doesn't resolve that. It does it really at the syntactic level, at the abstract syntax level. But however, we have been working on lifting a bit the conflicts to a semantical level. So for example, with Juan, we've been collaborating on some work on domain specific and semantical version control systems, where we ask the language engineer to provide semantic rules to define how conflicts can happen and how they are resolved, but from a semantical point of view. So I can refer to you. So there's one paper at the SLE 2019 about that for the differencing, and we're currently working on the merging part as well.
Mhm. In the meantime, while people warm up for additional question, I have the question that I'm not sure if you treat differently the conflicts that may happen at the concrete syntax level only, where one person moves something in one way and the other moves into another, and the conflicts that are really semantical, right? So I guess they are treated differently, or do
Yeah.
you care at all about the conflicts in the concrete syntax alone?
Yeah. So it depends on the mode you are in. Actually, I'm not sure if I can do that, but I had prepared here if I this, probably you will see it. Here I have done a screen share, so where I share both we're working exactly on the same view. And so, for example, I can decide to change. I did the model share, so I can decide to have my own representation here. So it's exactly the same model, but with different concrete syntax in that sense. So if I create an element here and I move it around, it will be completely there. So it depends on the different on the different mode you are in. So if you're in screen sharing, model sharing, so multi-view, multi-model, etc. So depending on which option you have chosen. So for example, if I disconnected from here, then in this case, if I even if I increase its scale, it will also increase it on the other side. But if I did a multi-view, multi-model, then scaling does not affect the semantics or the abstract syntax, and therefore won't be shown there.
Right. I think we have a question by Jan Conlane. Jan, would you like to ask it, or shall I read it?
Yeah, I can ask it myself. Maybe it's a bit complicated. So from my experience, when you're modeling, you're not after all these micro tasks where you do the conflict resolution, but you're doing a bigger task that consists of many changes. Like, in traditional software development, you elaborate a complete commit for Git, or even a series of commit that actually perform a certain task. Do you perform any conflict resolution on that coarser level? Because when you do this micro conflict resolution, of course, you do not run into the coarser issues, but you may end up with a completely inconsistent system because all the combined changes don't make sense together.
Yeah, absolutely, and that's a good point you make. And currently, we only do the atomic changes, but the coarser changes are actually quite useful, especially when we want to look at semantic modifications, right? So you have these fine granular modifications, maybe 3 adds and 1 delete of these specific 3 adds and 1 specific delete means, I don't know, something in a domain specific sense, but it's one action as a coarser level. So you can look at it as a atomic transaction where you either perform all these smaller actions or you perform none of them. And so you encapsulate them in what I call a transactional operation. But there are different ways of looking at that, and you can also try to see if you have multiple conflicting coarse grain operations that may be sharing the same operations, or maybe one is contradicting the other one. You may optimize also the operations to do, because maybe they're the first 2 adds are the same, but the third add and the delete are different, for example. So you only need to perform one of them. So there's all these things we can think of, but no, we don't support that for now.
All right, and I have another question, and that is, how do you deal with changes in one view that are invalid in the other view? So, for example, a dangling edge. Yeah. In a diagram. So you create a new connection in a tree, but you create the connection first, then connect the source. But at the same time, if you look at the diagram model, you have a dangling edge. How do you deal with these kinds of things?
Yeah. So the specific question you asked is one special case, because actually, as I mentioned a bit before, there are 3 cases we see. One is there's a constraint, over the views or over the models. One, there is some kind of physical link, right? Like a reference or something like that. And the third one is you have an explicit mapping that defines the consistency between them. So another model that defines the consistency between the two models. And so in your case, it may be, for example, in the reference, right? When we have an explicit reference and you delete one element, what happens if there are elements connected to it, but they're not in the same view where you deleted it, they're in another view. So, and that's what I mentioned about the cascading, the changes. And in our case now, what if something like that happens, then it will be kind of highlighted, and the chat will automatically open between the two people in the two different views. So they have to resolve it because we can't decide because it has too much side effect.
You have a chat integrated.
Yeah.
Oh, that's a good idea to resolve conflicts on the human level.
There's no way.
Right. So maybe I would like to have the final minutes with questions that are for all speakers or even for the audience, to have some kind of more general discussion. Because Sergin, for example, have been presenting all these very nice collaboration features, but then in the morning we have talked about the language server protocol and the graphical language server protocol. So does it influence in any way the fact that you have collaboration? So does this impact in the language server protocol, or it has no impact? So that would be my question. So maybe perhaps for Jan, maybe you have mentioned this morning the.
Yeah, this is one of the reasons why I put so much stress on having an authoritative model. And so one representation of the model, which is the ultimate truth, and everything else is derived from that. If that's text, as in my case for the language server protocol, you can use the concurrent editing of the text in order to have collaboration. And that's already there in VS Code. There's live share, and we're building something similar maybe in the future for Thea and Gitpod. So on that level, it will be pretty easy. On the graphical level, I'm, at least from the technologies that I'm after, I'm very skeptical that it's ever going to work out, because it was already very complicated to sync a diagram view on text, because they behave so different in terms of errors and syntax errors or validation errors and stuff like that, that it usually doesn't make sense to edit both at the same time, even for a single user. So that's my 2 cents on that.
Massimo has a question.
Yes, I have a question still for Jan, following up on this. So your text-first approach is very interesting. But then also we saw different approaches throughout the day, for instance, in MF Cloud with synchronization by model server. So do you believe that text first is the best approach in any situation, or do you envision some cases in which you don't want to do that?
Yeah, so I think what Typefox and was always also after was a pragmatic solution with little effort. And in that, I guess this text solution, especially Xtext, really made a dent in the universe. So that is really incredibly efficient to get your language implemented in short time. But of course, it's text, and it's very developer centric. So as long as your users have no problem to deal with Git or an IDE, I would always go for the text-first approach, because it integrates with all tools you already have. It integrates with other languages that you already have. You can just use it in the same IDE. It's not a separate tool. You don't have need any additional databases, conflict resolution tools, and so on. So in that case, that your users are actually developers or people who are used to using IDEs, I would always go for text.
Yeah, thank you. But I just elaborate a bit. Even in the case in which users are not unfamiliar with text, I'm wondering if reasoning in a text-based way poses some constraints to the graphical editor, like, for instance, to the kind of operations that you want to add to the graphical editor, because you start asking yourself, well, does this operation make sense in the language server protocol as a text-based operation? Does this influence the graphical editor some way?
Okay. Yeah, I guess what I've shown in my demo was reconnecting stuff, so or drawing a new connection, and that is definitely something that you cannot do with a language server command. So what you have to do is you have to create your own commands that encapsulate that action and execute them on the language server. So this is beyond doing a refactoring or beyond doing asking for content assist at a certain place. So it's basically about packaging user interaction into a command and then executing that where you have the model, and that's on the language server. So it's pretty powerful. I'm not sure about the constraints, in which cases this was gonna fail. I can't. Yeah, I mean, it's very generic. So,
okay,
but it's then beyond language server protocol.
Okay, great. Thank you.
All right. I would have another question. If for GenMy model, right? Because we also saw in that presentation, I think don't remember if Matthew or Blaso were mentioning collaboration, right? And they were mentioning synchronous and asynchronous. So is it the kind of collaboration scenarios that Eugene was presenting, where you have multiple users that can work together? Is it something similar what you have in GenMy model, or?
I suppose that I leave the question to Matthew, because he was the one that was presenting about the synchronous and asynchronous collaboration. If he's still here, I mean. I suppose that he's not. All right. Well, currently we have a synchronous collaboration. It's like when you're editing, for example, a Google document. And we are doing this because the hypothesis behind it is that on server side, the requests are always ordered. For example, let's say that you have two users, A and B, and that both of them are trying to make a modification. We suppose, I mean, the hypothesis is that at the API side or on the server side, the requests are always ordered, and so we always know which one of the users is sending the request first. So we are doing that modification, and then we are doing the modification of the second users. And this is basically like when you're editing a Google document. We're currently working on offline mode. And I suppose that this is what Matthew was referring as asynchronous collaboration. And the idea behind it is to be able, for example, to continue modeling, let's say, when you're taking the plane. But there are a lot of problems about after I mean, when the user finished with the offline mode and when he tries to synchronize the model with the current version. And this is why Matthew was talking about EMF compare. I mean, being able to compare the new version with the old version of the model, see what has changed, and then accept some of this modification, or for example, refuse some other modifications. Right.
Mm-hmm. All right. By the way, I think Felicien has another question. Would you like to read it, Felicien, or shall I do it?
Yes, you can read it.
All right. So to any speaker, probably to anyone listening, what general learning recommendation would you give to someone who wants to start thinking on how to migrate his approach to implementing a cloud-based DSL? Anyone want to take this one? Well, yeah, probably my recommendation would be to have a look at the presentations that we have seen during the day, and try some of the tools. Actually, there are some other possibilities that have also been mentioned but not really presented. No, like I think Massimo mentioned yesterday, Sirius on the web, or so, which I think is already available, and today WebGME have been also mentioned. So there are plenty of tools. So probably, I guess this would depend on the kind of DSL, whether your DSL is very big, or if it is a DSL based on, let's say, UML stereotypes. I think GenMy model was able to support that. So I guess it would depend, and also on the kind of complete syntax that you envision for your DSL. All right. Any other comment or suggestion we would like to discuss? Well, if not, thanks a lot to all the speakers. I really enjoyed all the presentations. I think they were extremely interesting, not only for me, I guess, but for everyone, to all ESRs. I think all presentations were really touching on many relevant things for the ESR projects, and I'm very sure that they will profit from all this knowledge. So thanks again to the speakers. If you want to send us your slides, we will be happy to put them on the website. And what I'm not sure is what will happen with the video in YouTube. Not sure if we can sort of link to the recording, because that would be, I think, very useful. And yeah, we'll try to do that. I think that would be very interesting for us, so that we can see again the presentations.
Yeah, sure. We have planned to put the video in our channel.
Yeah, that would be great. Yes.
Yeah.
And yeah, so I think that would be all. Thanks to all of you, and yeah, we'll keep in contact about this. Bye.
Thank you, Juan and Sorur, for the support, the organization, and the full day chairing that is probably exhausting.
Well, it was my pleasure. So interesting.